So here we have necessary components to prepare the circuit. Now just observe how I am preparing the circuit. First I will prepare the power circuit of 3-phase inverter. Now the hardware circuit is ready. Now I am going to integrate the 3-phase load with this 3-phase inverter as well as the measurement instruments with this load. Here our circuit is completely ready, but now I am going to connect the scope to observe the voltage and current of this 3-phase inverter. So here we have 3 scope arrangement for line current, line voltage and phase voltage. So now I'll give proper tagging for this go to block and from block. Okay, so now everything is ready and we are ready to implement the first technique, where we are going to implement a square pulses like this to this 3-phase inverter using the pulse generator. So let's prepare the circuit for that and then implement over here. For that we require only pulse generator. Period will be 0.02 second, pulse width would be 50%, and there we go. Here we are ready with our first pulse generator. Now in order to operate this 3-phase inverter, we require to operate all these 6 switches in several patterns. For this video, we are going to operate this inverter in 180-degree mode of operation, and for that the pattern will be like this. First we operate switch number 1, then 6, then 3, 2, 5 and 4. In different videos and in different book you find different numbers of switches placed at different location, but the fundamental logic and principle remains the same. To simplify this thing, you need to remember this specially designed X: 1, 6, 3, 2, 5, 4. This will help you to remember the switching sequence of this 3-phase inverter. So as per this logic, what we supposed to do, we supposed to operate the switch number 1 at 0 degree, switch number 6 after 60 degree, then switch number 3 after 60 degree, 2 after 60 degree. So likewise the switching angle for all these 6 switches will be like this. So as per the previously mentioned switching sequences, this PG1 will be given to switch number 1. So let me arrange go to and from block for this switch and pulse generator. So here we are ready with all the gate pulses from switch number 1 to switch number 6. So here switch 1, 3 and 5, these are the 3 switches of the upper section, and switch 6, 2 and 4 are the switches of lower section. Now we'll add one power GUI block. So whatever we need to prepare, we have prepared everything, and now it is time to provide a proper sequence to all the 6 pulse generators. So as per the gate pulse sequences, this pulse should start at 0 degree and then this PG6 should start after 60 degree. So let's arrange it after 60 degree. So this will give the delay of 60 degree. Then the next gate pulse is PG3 and that is on 120 degree. Likewise, I will set time delay for all the other pulse generators. So now everything is set and we are about to run the simulation. Instead of this much small time, I'll make it 1 second and then let's run the simulation. So first let's see all the gate pulses. So here you can see that these are the 6 gate pulses for this 3-phase inverter. And now we'll go for the phase voltage. So here you can see the phase voltage. So here is the VR, VY and VB three-phase voltages. Now let's see the line voltage. So here in line voltage you can see there are two steps, and in phase voltage you can see there are three steps. Now let's observe the current, and this is the output of current. So this is how this three-phase inverter with 180-degree mode of operation can be done. You can even operate this three-phase inverter with 120-degree mode of operation, with 150-degree mode of operation, and if you want to achieve those things, then you need to do slight arrangements in all this pulse generator. If you want a separate video on 120 and 150-degree mode of operation, then write in comments below, and if I get handfuls of comment, I'll make video on that topic. Now after implementing this simple square wave with this three-phase inverter, now it is time to go for the second method, and in this method we are going to implement the pulse width modulated signal to this three-phase inverter. So here we'll produce PWM signal for all the 6 switches. So in order to generate PWM signals we required several things. So let's gather those things. So these are the components that we require to produce a PWM signal. So how we'll produce these PWM signals? We compare a constant DC signal with the triangular wave, and then we compare both this wave. So when the magnitude of DC signal is higher than the magnitude of triangular wave, at that time we will get the output pulse. And this is how we are going to get the PWM signals. So now here let me arrange the circuit for this. Here the magnitude of constant block will be 1 and here the magnitude of this time value will be like this. This time value means we want a 20 triangular into the period of 0.02 second, and the peak magnitude will be 2. The result of this will be the PWM signals. Let us check this thing. So here you can see that we are getting the pulses. But let me tell you, whatever pulses we are getting at the output of these two blocks comparison, the pulses are continuous pulse. But what do we want? We want pulses in specific sequence for all the 6 switches. So in order to achieve all the pulses in specific sequence, what we are going to do? We are going to have AND operation between each of this pulse generator and the continuous pulse. So finally as a result what we get? We'll get PWM signal for that specific time. Let me have a logical operator here. So what we'll do? We'll do AND operation. The first will be this pulses and the second will be the output of this pulse generator 1, and that will be this. And now you can observe over here that we are getting pulses for specific time. Here it is continuous pulse, but here we are getting pulses for specific time. So likewise I will generate pulses for all the 6 switches. Now here complete setup is ready. So now the tag you can see over here, that should be same as the tag at the gate pulse of the switch. So now I will update all these tags. So here all the tags have been updated, and now let's run the circuit. First let's observe the gate pulses. So here are the gate pulses for different switch. The first one is the continuous pulses, and the second and third is the pulses for different switch. And now let's see the phase voltage. So this is how you can get the phase voltage of all the 3 phases R, Y and B. Now let's observe the line voltage. So these are the line voltage of VRY, YB and BR. And finally we'll go for the current. And this is the current of all these 3 phases. So this is how you can generate the PWM signal for three-phase inverter. Now just imagine, instead of this pulse width modulation technique, what if you can implement the sine pulse width modulation? That will improve the output of three-phase inverter. So in order to achieve improved output, we used to have sine pulse width modulation technique. So now we are going to implement the third sine PWM technique for this three-phase inverter. Now we'll gather all the components. So here we have got all the necessary components. What we are going to achieve over here, we are going to compare this sinusoidal wave with the triangular wave. And the result of these two comparison will get a sine PWM pulses like this in the output. So here, in order to achieve appropriate SPWM signal for all the 6 switches, we require a separate 6 sine sources for all the switches. And all these sine sources should be 60 degrees apart from each other. And then we compare everything with the triangular wave. So now I am going to prepare a circuit for that. So here the complete circuit is ready. So we have 6 sine sources. The first source parameter are like this. Amplitude we have kept as 1, frequency is set at 50 and the phase delay is 0. The next is for switch number 6. Now over there we have provided the delay of 60 seconds. Then the phase delay of 120 degree, and likewise in all the switches. So finally in the last switch the delay will be of 300 degree. And then we are comparing it with a triangular wave with the similar pattern that we have used in PWM signal. So here what we are doing, here we are creating 20 triangular signal in time of 0.02 second with the peak magnitude of 2, and the output is given to the go to blocks. And over here the from block we need to update the tag. So here we have updated the tags, and now let's run the circuit. So first we'll observe the SPWM signals. So this is how the SPWM signal for all the 6 switches looks like. Now let's see the phase voltage. So from this picture you can see that the output looks more sinusoidal. So this is the output of phase voltage. Now let's observe the line voltage. It's the output of line voltage. And now let's see the current. And here it is, the current of all the 3 phases. So here, by observing all these waveforms of line voltage, phase voltage and phase current, you can conclude that the output of this 3-phase inverter is better when we use SPWM signals. Now let me tell you, if you want to download this simulation file, you can join me on my Telegram page, and from there you can download this file. For more similar tutorials on MATLAB, you can watch my MATLAB tutorial playlist. So until we meet again in our next session, till that time, bye bye.